if you notice in the previous exercise, I mentioned that you had 3.8 grams of hydrogen and you had enough oxygen for everything to react. And that was because I didn't want you to worry about, oh, how much oxygen do I have? You had enough for all the hydrogen to react. And now I'm going to briefly introduce something called the limiting reagent. And the limiting reagent is basically what happens if you have too little of one of the reagents. If the amount of reagents you've got does not match up perfectly what you will need for all of them to react completely and make the product. So for example, imagine here we've got 5 slices of bread and 3 slices of ham, and I want to make a ham sandwich. So I can set up this, my making of ham sandwich as if it were a chemical equation. So I've got 2 slices of bread and 1 slice of ham will make me 1 ham sandwich. So with my 5 slices of bread and my 3 slices of ham, how many ham sandwiches can I make? And would I have any left over of my reagents? Have a little think, stop the video and tell me the answer. So imagine imaginary chemical reaction of 2 slices of bread, 1 slice of ham to give me 1 ham sandwich. With my 5 slices of bread and my 3 slices of ham, I would be able to make 2 ham sandwiches, and I would have some leftover reagents, 1 slice of bread and 1 slice of ham. And the limiting reagent in this case is the bread, because we have enough ham to make another ham sandwich. What we don't have is bread. We only have 1 slice and we need 2. So bread is the limiting reagent. Even if you had more slices of bread that you had on ham, it's still because you use it in higher quantities in the reaction, in higher proportions, it gets used and you have some left over. You cannot make as many ham sandwiches as you could theoretically do if you had more bread. You still have the ham, but not the bread. That is why in many times when you're reading a reaction or a method section of a synthesis or a chemical practical, you will see things like this amount of this chemical reacted with sufficient of this other chemical or with excess chemical. That's what they're trying to tell you. They're going to tell you this is the limiting reagent, and we put a lot of the other reagent to make sure that everything reacts. And that's something that we do very often in chemistry, to make sure that we don't find unknowingly that you have some leftover from both reagents. No, we're going to have sufficient of one of the reagents to make sure that the other will react. And yes, we will have some left over, but will be of one of the reagents rather than the 2 of them. So this is slightly beyond the aim of this module, but I thought you could have a little bit of fun, considering, depending on what you consider fun, but it's sort of chemistry type fun. We're doing some calculations using this concept of limiting reagent. So I'm giving you this reaction, the 2 moles of hydrogen reacts with 1 mole of oxygen to give you 2 moles of water, and I'm asking you, imagine you have 4 moles of hydrogen and 2 moles of oxygen. How many moles of water would you produce? And would there be any reagents, the hydrogen on the oxygen or the oxygen left? So stop the video now, please. So let's have a think about it. The reaction tells me that you need 2 moles of hydrogen to react with 1 mole of oxygen. So if you have 4 moles of hydrogen, how many moles of oxygen will you need? Well, hopefully you see that you will need 2 moles of oxygen. So 4 moles of hydrogen and 2 moles of oxygen will react completely because they are in the right ratio, 2 to 1. You have double the amount of hydrogen that you need of oxygen. And how much water would be produced? Well, you would produce, if you look at these 2 coefficients here, you would produce as much water as you have hydrogen, or if you prefer to look at the oxygen and the water, you would produce double the amount of moles of oxygen you've got. So you can look at it in both, because in this case, you're not going to have any hydrogen or any oxygen left. So let's write here, no, there are no reagents left. How many moles of water would it produce? Well, the same number of moles of hydrogen you've got, which is 4. Or if you want to look at it with respect to the oxygen, double the number of moles of oxygen you've got, which again gives you 4. So you will produce 4 moles of water and nothing will be left over of the reagents. So now let's have a look at the problem. And it's the same problem, but now I'm telling you, you've got 6 moles of hydrogen and 2 moles of oxygen. So how many moles of water would you make? And would you have any reagents, any hydrogen and any oxygen left? Stop the video now, please. So now, if you have 6 moles of hydrogen, how much oxygen would you need? Well, the reaction is the same reaction. It tells you that you need double the number of moles of hydrogen that you got of oxygen. So if you want your 6 moles of hydrogen to react completely, you will need half of that amount, 3 moles of oxygen. But you don't have 3 moles of oxygen. You only have 2. So those 6 moles of hydrogen, if they're going to react completely, will need 3 moles of oxygen, and they don't have them. You only have 2 moles of oxygen. So oxygen is going to be, these 2 moles of oxygen are going to be your limiting reagent, because you have sufficient hydrogen for the reaction to continue, but you run out of oxygen. So you need to make your calculations with respect to that oxygen, because that's going to determine how much product is going to be formed and if you're going to have any left over. So let's have a look at the 2 moles of oxygen. 2 moles of oxygen, how many moles of hydrogen do they need to react? Well, the reaction is 2 to 1, 2 of hydrogen to 1 of oxygen. So if you have 2 moles of oxygen, you will need 4 moles of hydrogen. And that's okay. You have 4 moles of hydrogen, you actually have 6. So yes, your 2 moles of oxygen will react with 4 moles of hydrogen, and you would end up with 2 moles of hydrogen left. So you would consume all the oxygen, no oxygen, would all react. You would consume 4 moles of hydrogen, and you would have 2 moles of hydrogen left over of those 6 moles. And how much water would you make? Well, now you can't look at the hydrogen anymore. You can look at the oxygen. You need to have to look at the oxygen, because it's the one that is going to determine how much oxygen you've got. It's going to determine how much water you're going to make. So now the calculation is to be, okay, well, if I have 1 mole of hydrogen, if I have 1 mole of oxygen, it gives me 2 moles of water. Well, if I have 2 moles of oxygen, I'm going to make 4 moles of water, and double the amount of oxygen I've got. So as in the previous case, we still make our 4 moles of hydrogen, our 4 moles of water, but in this case, we do have reagent left. We have 2 moles of hydrogen left, because oxygen in this case is our limiting reagent. And we cannot make more water because we run out of oxygen. So the hydrogen has nothing to react with.